Welcome to SERVOsoft, size-complete servo systems. This tutorial demonstrates SERVOsoft's ratio analysis tool. The ratio analysis tool is available for each transformation. It works on a very simple principle. It takes the system as it is and replaces the existing gear ratio with a range of ratios specified by the minimum and maximum values. The chart displays the performance results on the chart Y scale versus the gear ratio on the X scale. The step value specifies the calculation resolution. For example, if the min value is 1, the max value is 20, and the step value is 1, then calculation will use the ratio 1, 2, 3, and so on up to 20. If the step is 0.5, then the calculation will use 1, then 1.5, then 2, then 2.5, and so on up to 20. Depending on the design criteria, the objective may be to minimize the inverter peak power, or the motor RMS torque, or the motor inertia mismatch. The ratio analysis tool allows the user to see the performance results for a range of gear ratios. Performance results displayed in the chart include motor peak torque, motor RMS torque, inverter peak current, inverter continuous current, inverter output peak power, inverter output continuous power, inverter regen peak power, inverter regen continuous power, motor speed, gearbox input speed, which is the transformation 1, and the motor load inertia mismatch. If the chart looks a little cluttered, click the Select Profiles button and choose which profiles to hide. For example, let's say I am interested in just the motor peak torque and motor speed. And here we have just the two motor profiles visible. Note that the ratio analysis tool does not change the project in any way. Now I will close the form. Let's look at the single axis project, which has a gearbox with a 5:1 ratio and a motor inertia mismatch of 6.5:1, which is a little high, but still acceptable for this application. Let's see if there is still some motor speed margin available. With the current 5:1 gearbox, the motor torque versus speed chart shows that the maximum motor speed is 2,984 RPM, so I have some speed margin to work with. Using a higher gear ratio will reduce the inertia mismatch, but will also increase the braking power, so as in many design decisions, there is a trade-off of benefits. Now I'll go to and open the ratio analysis tool. Now let's see the effect on our system if we vary the gear ratio from 1 to 20. I'll use a step value of 0.5. The chart clearly shows that the inverter peak power is minimized at a gear ratio of 5:1 or 6:1. As with all the charts in SERVOsoft, click on the legend to increase the profile line thickness so you can easily find the profile. As I have done for the inverter output peak power, the inverter regen peak power, the inverter regen continuous power, and the motor inertia mismatch. I will zoom in around the 5:1 and 6:1 ratios to examine what is going on in this region.
So as the ratio increases from 5:1 to 6:1, the inverter regen power is increasing from 6,633 watts peak and 639 watts continuous to 7,271 watts peak and 705 watts continuous.
While the inertia mismatch is reduced from 6.5:1 to 4.5:1. So as expected, using a higher gear ratio reduces the inertia mismatch, but also increases the braking power. As in many design decisions, there is a trade-off of benefits. However, in this case with the existing 5:1 gearbox, the inertia mismatch is acceptable and offers a modest savings in energy costs of about $75 per year. Furthermore, and most importantly, the next highest available gear ratio is 7:1, as a 6:1 is not available from the manufacturer, so we will stay with the current 5:1 gearbox. This concludes the SERVOsoft tutorial on the ratio analysis tool. Thank you.